Hi guys, this is Thomas Beck, and today I'll be teaching you about the mole. Moles can be pretty confusing. It's probably the word that puts people off. It's difficult to see the relevance of the word mole to anything but a small burrowing animal. The mole is simply the name given to an amount of a substance. Just like a million is this many, or a billion is this many, so Avogadro's constant is this many. And that's all there is to it. It's just a number. 1 mole of any substance is just an amount of that substance that contains an Avogadro's number of particles, so 6.02 times 10 to the 23 particles. The particles could be atoms, molecules, ions, or electrons. The burning question, of course, is why is it such a silly long number like that? The answer is that a mass of that number of atoms or molecules of any substance is exactly the same number of grams as the relative atomic mass, or the relative formula mass, of the element or compound. In other words, 1 mole of atoms or molecules of any substance will have a mass in grams equal to the relative formula mass for that substance. Here are some examples. Carbon has an atomic mass of 12, so 1 mole of carbon weighs exactly 12 grams. Nitrogen has a molecular mass of 28, 2 nitrogen atoms that both weigh 14, so 1 mole of nitrogen gas weighs exactly 28 grams. Carbon dioxide has an MR of 44, so 1 mole of carbon dioxide weighs exactly 44 grams. This means that 12 grams of carbon or 28 grams of nitrogen or 44 grams of carbon dioxide all contain the same number of particles, namely 1 mole or 6.023 times 10 to the 23 atoms or molecules. It is a nice formula to find out the number of moles in a given mass. The number of moles equals mass in grams of an element or compound divided by the MR of the element or compound. So, how many moles are there in 66 grams of carbon dioxide? Step number 1 is to calculate the MR of carbon dioxide. The MR of carbon dioxide is 12 plus 16 times 2 equals 44. Use the formula. The second step is to use the formula above to find out how many moles there are. Number of moles equals mass divided by the MR, which in this case is 66 divided by 44, so 1.5 moles. Easy peasy.